This is Mr. M back here for lesson number 5, talking about properties of logs. Not that kind of log though. Talking about logarithms. So right away, I'm going to put up this chart for you. Right? Notice how it says name, rule, and example. Okay, you're going to have to write down each of these 4. I'm sorry that kind of got cut off at the top, but I need you to write down each of these 4. So pause this, resume it when you're done writing it. Did you write it yet? Hoping you did. Okay, you're going to want to keep this around because we're going to be referring to each of these properties throughout the rest of this lesson. Okay, I'm not going over this. We'll go over this in class itself. So if you're watching this out of class, come in with your questions instead of me explaining it here. It'll be way easier that way. Alright, so let's see. We're going to have a couple of different types of questions. Okay, the first type, they're going to give us a log base and a value equal to something approximately, and we're going to want to evaluate. Okay, that's what the first type of questions will look like. So here they tell us log base 7 of 4 is approximately 0.71. We want to evaluate log base 7 of 196. Now, the first thing that I want to do is I want to break this into some numbers that I can work with. And generally speaking, the log base is going to show up somewhere. And if not just that one, but whatever's in here, it might even show up along the lines too. What do I mean by that? Well, if I do log base 7, 196, if I was to divide that by 4, it would give me 49 out. So I got 4 times 49. Notice how I said that 4 might show up. Well, log base 7 of 4 times that 49, that's really like 7 squared. I also said that 7 might show up, and it did. That was one of our first properties. That was just the product property, right? Breaking it up. Now I can break it up even further, right? This product property comes in where this multiplication in between, I'm going to break this up into 2 different pieces. Log 7 of 4, and I'm going to add log 7 of 7 squared. This, they told us, was approximately 0.71. Here I have log and the same value. So these things are just going to eliminate, and I'm left with 2. So I have 0.71 plus 2 gives us 2.71 as a solution. By the way, that last step that we just did, that would have been your inverse property. Okay. Let's take a look at that second example. Let log base 3 of 6 be approximately 1.63. We want to evaluate log base 3 of 36. Okay, so we're going to think about what that 36 can break up into. What I'm thinking of would be 6 squared. All right, so let's take log base 3 of 6 squared. The power property, because this base doesn't match here, power property comes in. That 2 is going to come in front as a multiplier. But this isn't bad news because log base 3 of 6 was given to me here. So I have 2 times, this is going to be 1.63. And if we multiply 2 times 1.63, we get 3.26. Okay, so we were just using that time only one of our properties. So I've got a couple of problems for you to try right here. Pause the video and resume when you're ready to check your solutions. Okay, it was just the top 2 that you were doing, right? Log base 4 of 320. So I'm going to divide by 4. I'm thinking of doing that. Actually, that might not work. If I divide by 4, it's not going to look too good. So the next thing I might want to try is dividing it by this 5. Let's try that, because I'm hoping to get a 5 in there somewhere, right? So if I divide 320 by 5, it gives me 64. That's actually good news, because 64 is really 4 to the power of 3. So we've got log base 4 of 4 to the power of 3 times 5. Why was that good? Because I have a 4 and a 4. I want that. We're going to use the product property, break this thing up. Log base 4 of 5 they give us is 1.16. Log base 4 of 4 squared, that eliminates, and that just gives us plus 2. When we add, oh, I'm sorry, that's not a 2, that's a 3. Sorry. That was a 3. That should have been a 3 there. When we add 1.16 and 3, we get 4.16. Sorry about that. Sometimes my 3's and 2's change on me. Sorry. The second problem that you had on your own, log base 9 of 4, they want us to evaluate log base 9 of 16. So I'm thinking 16 should really be 4 squared, right? Log base 9 of 4 squared. Because my base does not match, that power property rather comes in hand. So it's going to be 2 times log of 9, log base 9 of 4. We know what that's equal to. It's equal to 0.63. So 2 times 0.63 is 1.26. Those were the two that you had to try on your own. I'm hoping you didn't try that one yet, because we haven't gone over it. Let's go over it right now. We're going to solve for x. And again, we're going to want to just make sure that we don't have any extraneous solutions. Okay? So this time we're kind of working a little bit backwards. This time I want this 2 to come inside. Right? So I'm going to have log base 5, and that's going to become x squared. And here I'm going to join these together using the product property. So I have log base 5 of 9 times 4. Why am I doing that? Because now I just have log base 5 on both sides, right? And I can eliminate the logs altogether. What that gives me here is x squared, and over here 9 times 4 is 36. And then I can take the root of both sides, and we get plus or minus 6. Now here's the thing. Can I have negative 6 inside? No, because that's going to give me a negative, and it won't work. It's not allowed. So my extraneous solution, we get rid of the negative. Positive 6 is going to work. That's my solution. Okay, so you have a problem to try out right here. It's possible you might end up having to check your extraneous solutions. So pause this video and resume when you're ready to. Alright, let's see how you did. I'm noticing this addition right in the beginning tells me product, right? Multiply. So that's going to be x times x plus 6. We'll have to distribute. So x squared plus 6x. This is a little bit different from the last one, right? At this point, I don't have a log base equal to a log base, so we can't just eliminate. What we're going to have to do is we're going to have to change this to exponential. So I've got 2 as my base to the power of 4. That's equal to x squared plus 6x. I hope that you didn't get stuck at that point. If you did, let's just pick it up anyways, right? 16 equals x squared plus 6x. We'll subtract 16 from both sides. So we get x squared plus 6x minus 16 equals 0. We're going to have to factor. One's going to be positive, one's going to have to be negative. The larger will have to be positive. I'm noticing 8 times 2. Right? If I do positive 8 and negative 2, That's going to give me positive 6 here when we add, and negative 16 when we multiply. So that worked. If we set each equal to 0, we get negative 8, we get positive 2. Can I plug in negative 8 here, though? No, because that's going to be a negative logarithm. Doesn't work. Can I plug in 2 for either of those? Sure. That's not going to give me a negative. So x equal 2, it is. A few more. Okay. Here we have log base 5 of 7 minus 2 log base 5 of 6. Here, all we're doing is simplifying, not solving, so we don't have to worry about extraneous solutions. We just want to make this as small and with only one log if possible. So we just look at what's going on, right? I notice right here I have a 2 in front. I don't want the 2 in front. It needs to go inside, right? So we've got log base 5 of 7 minus log base 5 of 6 squared, right? That's just the power property. Now I notice this negative, right? This minus. Quotient property should come in, right? I have the same base, so if I notice that negative, I'm going to divide, right? So we got log base 5 of 7 over 6 squared is really 36. That's it. I have only one log. That's as simplified as that gets. Mr. M hates decimals, so we'll just leave it in fraction form. Second example, a little more complex, right? We have 1/3 log 3 of 27 minus 1/2 log 4 of 16. Really not that much different though, right? Anything on the outside we're going to bring in using that power property. So we got log base 3 of 27 to the 1/3 minus log base 4 16 to the 1/2. That would be cube root of 27. The cube root of 27 is 3. And here that would be the square root of 16. The square root of 16 is 4. Now we have log base of 3 equal, log base of 3 of 3. That is the inverse property. I have a 1 that's not shown here, so that's just going to be 1. I have the same inverse property happening here, right? I have a power of 1 that's not shown. These eliminate. That gives me 1 minus 1. 1 minus 1 is 0. So we had this problem to start with. We simplified down to nothing. Okay, you have 2 examples to try on your own, and you can resume the video when you're ready to check your solutions. Alright, let's check these out. First, we want to deal with this power property. So log base 5 of 2 to the 3rd plus log base 5 of 4. Well, 2 to the 3rd, that's 8. And I notice this addition means product, multiply. So I've got to multiply 8 times 4. So we get log of 5 of 8 times 4, which is 32. So you should have come up with log base 5 of 32. Okay, your second problem, very similar. We need to use the power property. So log base 3 of 32 to the 1/5 minus log base 3 of 2 squared. 32 to the 1/5. I hope that didn't stump you. That was just going to be 2. Okay, log base 3 of 2. Here we get log base 3 of 4. Subtraction is quotient, so we've got to divide 2 by 4. And we can still simplify. 2 over 4, that's going to simplify to 1/2. Log base 3 of 1/2. I'm hoping that you got those problems as well. Logarithms, simplifying, really not bad once you get used to the properties. There's only 4 for you to have to memorize, and they're pretty straightforward. So if you have any questions on any of this material, leave them in the comments or bring them with you to class. I think that's a better idea. In fact, I'll be able to answer them for you there. All right, see you soon.